Welcome, Sage. Frank. Pia asks, is this for creating games? Yes and no. The primary purpose here is to teach some of the fundamentals of using any computer programming language and just computer programming in general. So it just sorts out some of the basics that everybody on this learning journey in code will need to know. As a tool for teaching those fundamentals, we use this Pong game. We do this with several other games because games are fun to build, right? And as we'll go over in some detail, we'll accomplish both things. We'll teach you, and you'll actually get your hands dirty writing code. We'll teach you the fundamentals of any computer program, writing code, and we'll also give you the complete code for a working game, a Pong game. It's actually pretty fun to play, and show you how those fundamentals of computer programming are present in that entire code and go through it, in some detail. So at the end of it, you'll actually have a working game that you can tweak and have fun with as you like. And if you want to go and create a different game, you'll be equipped with at least some of the fundamental principles involved. That and a few Google searches, that's great. A few Google searches, and you could probably put something together. So I hope that answers that, Pia. All right, we're getting close to the Super Bowl. Some people care, some people don't. I want you to throw in the chat who you're rooting for in the Super Bowl. Although if it's not the 49ers, I'm sorry, I just don't know what to say. Even though I'm like probably the biggest Taylor Swift fan in the world, not going to vote for the Chiefs. Not going to root for the Chiefs. And apparently I am the only one that gives a rip about the Super Bowl. That's completely fine. Look, I was born in San Francisco. I was raised north of there. The Niners win the Super Bowl. I'm super excited. Thank you, Lee. Rah, rah, San Francisco. Regina, why you got to do that? Regina pops in with a Go Cowboys. I honestly don't know if there's an NFL team I dislike more than the Cowboys.
I just know how much you love them.
Oh, thanks. Thanks so much. America's team. All right. So we're 2 minutes after. You guys have been great for being on time. So we'll get started with the folks that are here. And if we have some late arrivals, again, these are recorded and I'm sure they can catch up. Awesome. We got some people arriving as we speak. Welcome. I'm really glad you're here. I'm Erik Gross. I'm the co-founder of the Tech Academy. Welcome to today's workshop. So that's me in younger, less gray hair days, but at least I had a smile on my face when we took the picture. I'm a senior level software developer. You can call it a developer, an engineer, a coder, a programmer. Honestly, at a certain point, it's all just semantics. I've worked with technology since I was around 11, and I love computers, and I love teaching about computers. I spent 6 years in the Navy as a nuclear reactor operator and electronics technician. And I bring that up because, one, I'm proud of my service, but two, the knowledge I gained in the Navy and the experience I gained actually has had a tremendous influence on how we teach technology for a lot of reasons. I'd be glad to talk about it in detail. But one of the principal factors is that in the service, and in the Navy in particular, when they're teaching you something about technology, it's done against a backdrop of you are learning this so you can apply it in the real world on a real ship where if you don't apply it correctly, people die. It's just the way it is. I don't mean to be so blunt about it, but it's true. And rather than being a real negative thing, it was actually supremely effective because when you're learning something new, you're constantly thinking, how do I apply this in the real world? It's not just, oh, that's interesting as a theory. It's, oh, what's this going to look like when I'm working on real machines, when I'm doing real programming, when I'm operating a reactor, when I'm doing repairs. And so when we teach for application. How do you actually do this in the real world? Enough of that. So yeah, spent some time in the Navy. I'm also the co-founder of the Tech Academy, as I mentioned. More about that in a moment. We have an assistant in the chat. Many of you have attended a few of these classes, are familiar with Regina. She's awesome, except for her love of the Cowboys. I don't know what to say about that. Everybody has faults. So please use her. She's watching the chat, can answer questions for you. If you're not a nice person, which I don't think we'll have to worry about that. You all seem awesome. She'll boot you, but that rarely happens. Speaking of the chat, please use it. right? It's pretty simple. If you haven't used it before, look at the Zoom icon, find the chat button, click on it, and you should be good. Drop me in the chat right now. Where are you joining us from? I'd like to see where people are connecting in from around the country and around the world. So can you drop in chat where you're joining us from? DC, Washington State, Seattle, Calgary, Toronto, Cleveland, New York. Hey, Jeremy, you're welcome for I appreciate the acknowledgement of my service. Becky's joining us from Vancouver, Washington. Love it. Portland, Oregon. Lived there for 30 years. Love that town. Okay, good. Awesome. Glad to see you're all here. So here's the basic agenda. We'll have a short explanation of the Tech Academy, and then we're going to jump into our workshop. And this is a practical workshop. You get the most results out of it by actually following along and doing the coding. It's one thing to read about coding and, as I said before, grasp the theory of it, but the theory becomes real when you apply it. So once we're done with that workshop, we'll have a brief Q&A session. We'll go over some information about our boot camps, and there's a free gift at the end. Please stick around for that. The whole class should take about an hour, hour and a half. Oh, Lee is joining us from Belgium. That's fantastic. All right, so brief word about the Tech Academy. We run coding boot camps. Coding boot camps are intensive training programs designed to give you the practical tools to succeed in a technology role in a short period of time. They are one of three valid ways to get into the technology industry: self-study, coding boot camps, and colleges or universities. That's kind of the ecosystem we live in. In terms of the Tech Academy, we have 10 years of experience delivering coding boot camps. We've been offering thorough, budget-friendly, flexible, and trusted boot camps for over a decade. In fact, later this month, where you should check our events page, we'll give you the links later on. We're gonna have a celebration of our 10-year anniversary. I'm super happy about that. Our certifications, our programs are beginner friendly. They're cost effective. They're tailored for beginners. So they're for people that have no prior technical or coding knowledge, which is really nice. We like to break down the gaps or the bridge between people and technology. And that's what we're all about. We teach in-demand skills that the tech industry needs and wants. Our programs are endorsed by fantastic reviews online. And most importantly, they're designed to fit around your personal schedule. So we can prepare you for your tech career, and we give you a well-rounded toolkit so you'll do well in the long term. They're really well priced. The national average for boot camps is around $13,500. Ours are under the national average, and we've been have programs starting as low as $5,300. And this one I'm going to read verbatim because it's so important. The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. So that's our mission. And our product is you working in tech. All right, so let's go down some expectations, what this class is and what it isn't, okay? This is wrong. I'm going to fix it immediately. I grabbed maybe the wrong one because there is writing of code. So let me just make a change right there. I apologize for that. To me, a good amount of writing of code. It's a lot of fun, okay? So one of the things that we're going to cover here is simple definitions for technical terms. One of the things that makes it really hard to break into technology, and it drives me up a wall even after 40 some odd years of programming computers. One of the things that really drives me up a wall is that all too often, the technical terms that we use inside the industry are made very difficult, and they shouldn't be. Don't know why they are. They don't need to be, but they are. And so we endeavor to be able to explain these concepts in very, very simple fashion. Okay. The other thing we're going to cover is a bunch of technology related concepts, not just definitions, right? Like, how do these concepts work? And we're going to cover those through teaching you to code. Along the way, you're going to learn a lot about how computers work and how you can be in control of them rather than just be a consumer of technology. So let's move on. And we will switch over to our class. We're going to do some coding. All right. Okay. So some basic definitions. What is a program? It is a set of written instructions that are entered into a computer that make it perform specific tasks. Now, I want to separate out two things in your mind. There's a lot of programs that we've all used where you are, to a certain degree, as the user of the program, able to control what that program does. As an example, many of us have used spreadsheet programs like Excel. In Excel, you can write in, like, you can make it do math. You can put in, like, a command that will take a column of numbers and add them up and give you the total, give you the sum. It's a basic operation. From a certain point of view, you, as the user of that program, are entering in instructions into a computer and making it do something. That's not programming. I'm not saying that to denigrate it. People who are quite skilled in Excel are really valuable. Programming is creating the things like Excel, creating the program itself, creating something like Microsoft Word, creating a game. So the instructions we're talking about is the instructions that make the computer provide functionality to others. Using the Excel example, programming would be making the computer present that interface of rows and columns and provide the functionality that a user would need in a spreadsheet. That's what a program is. It's that set of instructions. So, of course, programming is done in a programming language. If we're entering in these instructions, what do the instructions look like? Well, what's really interesting is often they look very similar to English. But what they really are is a very precise set of words and symbols that a computer can actually understand. A computer can read through these words and symbols that you enter in, and they understand what you are telling it to do, and the computer does that thing. Something as simple as printing something on the screen. It can read through what you entered, and if you entered it correctly, it'll print it on the screen. We're going to do some of that later on, right? We bring this definition up because while programming languages very often look like English, they use English words, common symbols, they aren't actually English. They must obey exact formatting. They must be written in an exact fashion in a way the computer has been prepared ahead of time to read through. The most important aspect of that is a computer cannot, quote unquote, figure out what you mean. If you write something that's close to what it's supposed to understand, but not quite perfect, you and I looking at it could probably figure out what it meant to be. A computer is unable to do such a thing. It requires specific, exact instructions. And you're going to see that today when you get your hands dirty writing code. It's very common that you'll make a little bit of a mistake in writing something in, and the computer will be like, I'm sorry, I don't know what to do with that. And you're like, well, it's really close. Close isn't good enough in programming. All right, so last thing is, what is this word coding? Well, this is a verb, which means actually entering those instructions in. In a few minutes, you'll be sitting there along with me, entering instructions into a computer and making it do work. That is coding. Again, you can also call it developing. You can call it programming. Those are all the same sort of word of entering in the instructions. All right, so some basic definitions are out of the way. Let's talk about the language we're going to use today. JavaScript is super popular. There's thousands of computer programming languages, but when they rank computer languages every year for how common they are, how often they're used in the technology industry, JavaScript for several years has been in the top 1, 2, or 3, no matter how you rank it. So JavaScript originally was created as a way to take web pages and make them interactive. give them special functionality. I know that sounds bizarre because almost all web pages now are interactive. You can, click on buttons and roll over images and they change character and there's all kinds of stuff. When the internet came out in 1994, that wasn't around. They were just static pages, and JavaScript makes them dynamic. But you can do so much more than just work on web pages with JavaScript. It's really awesome. Okay, I want to cover these two different technologies. The first one is HTML. That's hypertext markup language. HTML is a tool to control the appearance of a web page. In other words, you might have some content on a web page, like some words that you typed, but you also need a way to control what does it look like on the page? What font is it in? How large is that font? Are some of the words different colors in other words? Are some of the words italicized? If there's images on the page, do they have a border around them? Do they not have a border around them? How big are the images? All of these concerns are controlled by this really cool language called HTML. It stands for Hypertext Markup Language. Very common technology. And then there's CSS. It stands for Cascading Style Sheets. If you've got a website that has a lot of pages, which many websites have a lot of pages, it's very useful to have one central place where with one change, you can affect the style or formatting of most or all of the pages in your whole website. And that's what CSS does. It stands for Cascading Style Sheets. And it means that if you make a change in one place, it can cascade or waterfall down into all of the other web pages on the site. Really valuable. These three technologies you see on the screen are the primary technologies of doing web development, software development for the World Wide Web. And they're really valuable to know these three things. But again, we're gonna cover the fundamentals of programming using JavaScript. And based on that, you can jump off and start learning some of these other technologies. All right. Now, before we have you write code, there's an extremely important thing to teach you. And I want to make a point here. I'm going to talk about our schools for a second, not to like proselytize about them, but because there's a lesson here for how to learn a complex technical subject. One of the things that's very common when people are trying to learn to code is that the very first thing any educational resource for them has them do is write code, which on the surface of it seems to make sense. Hi, I'm Eric. I want to learn to code. And you find a resource on YouTube and you start using it. And the very first thing they have you do is write code. It's a mistake, which sounds odd, but it is. And let me explain. There's a piece of data that's necessary before you start writing a line of code. And that is, if I'm going to write code that's going to end up creating a computer program, what are the fundamental elements of a computer program? In other words, what's the context that I'm learning to code in? If I'm going to make a program, what are the kinds of things that need to be in that program? And when you do know those, and now you start to learn a language, and when you start to, a computer programming language, and now when you learn, quote unquote, to code, you have a mental model for the things you're learning that make everything fit. They align much, much better. And that's what we're going to do here. I'm going to teach you 5 elements to any computer program. Any program you ever create, any program you ever work on, if you get into the industry, will make use of these 5 elements and no more. These are the only 5 things that are in any computer program. So the final reason we teach this is it simplifies things and it can make things a lot less anxiety producing when you're learning a complex subject like programming. So on to these 5 things. The first element any computer program has is what we call an entrance point. Now, We said that a program is a series of instructions that you put into a computer to make it do work, right? And that's true. It is a series of instructions you put in. But it's important to think about how the computer performs those instructions. A computer can only do one thing at a time, and it does things in an exact order, which means when you're creating a program, you've got to tell the computer where to start. What's the first thing you're supposed to do? It's like, hi there, I'm the computer. Eric, you're telling me to run this computer program. All right, what's the first thing I do? That's what the entrance point is. And it's important for a lot of reasons, not the least of which is when you as a programmer need to work on a program that you've been given, it's really valuable to be able to go to the earliest point in the program and start tracing through and seeing what this program does. So that's one element. Second element is variables. Variables, now look, computers keep track of data. In fact, the purpose of a computer is to take in data, work with the data in some way, and then send the data on somewhere. Take in data, work with it, send it on. So you're working with data. While your computer program is running, some of the data it works with is likely to change. And the way you keep track of that in your programs is by creating a thing called a variable. It's just a way to keep track of data that will change while the computer program is running. If you don't have them, then you're only allowed to use data that can't change, and that isn't very useful at all. We build programs to handle real-world, problems, and very often the data surrounding the problem changes. All right, the third element of any computer program is what we call control or branching instructions. You've got to have a way to control whether the computer does one thing or another based on certain criteria. Now, why would that be a fundamental element of any computer program? Because I can't think of a single computer program you would ever write that wouldn't at one point or another make a decision for you. We use computers to automate things we can do manually. We could do them in the real world. And what we do quite often in the real world is we make decisions about things. Well, control and branching instructions let you control what gets done, and the different options are called branches. The fifth element of any computer program is what we call subprograms. When subprograms were developed in the late 50s, early 60s of last century, shut up, I'm old. But when subprograms were developed, it utterly changed how useful computers could be and how easy it was for programmers to control them. A subprogram is basically a program within a program. And what it means, and you're going to build one today. What a subprogram is this concept right here. If there's a type of action that you're going to take over and over again in your computer program, and that action requires an exact set of instructions, then it's much smarter to take that set of instructions and set them off to the side in a little package, a little subprogram with a name. And then whenever the rest of your program needs those actions to occur, you just call on that subprogram and say, hey, can you do your work now, please? And it'll do it. And then you'll come back where you were when you left off. You'll see that in practice in a little while here when we're coding. That's a subprogram. And the final element of any computer program, is an exit point. Where they go, an exit point. There needs to be some way for your program to tell the rest of the computer, hey, I'm done. I've finished my work. Anything that you, like the operating system, of the computer, anything you were doing to help support me doing my work, you don't need to do that anymore. This program is over. It's ended. So these 5 elements are present in every computer program. Now, they're not in this order exactly. They're just the building blocks of any program. Now, having seen that, let's start building some. First, let's go over where you're going to actually build your code, where you're going to write this code. We're going to use a tool called a code editor. There's thousands of them. The one we're going to use is this nice little one that's available online. Regina's going to drop that link into chat, and I'm going to pop mine open. This is what you'll see right here. So go ahead and grab that link from chat and open up that code editor. Give a second for people to get all set up with that. Okay, so I want to try to set it up. I want you to set it up so that you have my display, i.e. Zoom, on the left, and this code editor on the right, so you can follow along and do what I'm doing. So it'll look like this. On the left will be my code, and on the right will be your code. Now, what that really means is on the left-hand side of your screen, you're going to want the Zoom window that you have open right now. And on the right-hand side of the screen, you're going to want this web page that has the code editor in it. So depending upon your operating system and your computer, there's a couple ways you can do that. A lot of the times you can simply drag and drop a window to the left or the right, and the operating system will automatically, boom, take up half of the screen. Sometimes, especially with Zoom, you've got to click right on the Zoom meeting words, and this little menu will pop up. You click restore, and it'll make Zoom smaller, and you can move it around to where you want to, and you can kind of resize it. Okay. But regardless, we want to have a setup where on the right-hand side is one screen, and on the left-hand side is another screen. So I'm going to give you guys a minute here to get that set up, and then we're going to write some code. Can't wait. Yes, I'm a nerd for this stuff. Yeah, just as a true confessions time, even writing the small little bits of programming that we do to prep for these classes, I just get a blast out of it. I get a kick out of it every single time. The fact is, there's just something, this isn't for everyone. I got it. That's why we do these classes, to find out if this is for you. But for a lot of people, just being able to tell the computer to do a thing and it does is really cool. And trying to tell the computer what to do and it doesn't work at first, and then you fix it and it does work, that's awesome. All right, so let's get into the coding. First of all, the program that we're going to build is a Pong game. Now, I know there might be some people in the class that don't remember the game Pong. I'm going to show you what it is. Don't follow along yet, okay? I'm just going to show you the code. Oh, sorry, I'm going to show you the program working. All right, now let me make this a little bit smaller so y'all can see what's happening here. Move this over. Okay, so over here, I have, why are you not being nice? Just a second. I've got some resizing issues. There it is. Okay. So I have a paddle on the left. I'm the blue one. I'm controlling that with my mouse. And I've got a bouncing ball. Oh, okay. On the right is the computer player. And I just have to try to catch the ball. So it's Pong. A lot of you have already seen this in the past. Some of you haven't. I get really nerdy about this. This was the first computer program that was, computer game that was ever made available to the consumers. It was in 1978. And the reason I know it was 1978 is because I was 9 years old. My dad bought this and he had to put an overlay on our TV, a big plastic sheet that showed the playing field, like this big square. And then we had these little teeny controllers that were like a knob you can turn, and it would move the paddle up and down. Like, that's how old school this game is and how old school I am. But that's the game that you're going to look at today, okay? And it's the backdrop for how we're going to code. So I'm going to stop right now. Actually, let me just go and lose the game. But we're going to go back to writing some code, and rather than write out this entire program, like, look at this code. there's a lot going on here. There's a lot going on here. We're not going to write all this out. We'd be here for hours, and you'd probably want to, tear your hair out by the end. But two things on that. One, you are going to get a copy of the full code that I just showed you, and you'll have some understanding of how it's built, what the parts are. You'll be able to analyze it by the end of this class. Final point I want to make is graduates of our program could read through all this code and understand exactly what it was doing, and they can even build this thing themselves and work on it and improve it over time. All right, so let's go back to what you will have seen when you started. Let me enlarge this, make my font size bigger. Okay. So let me explain what we're looking at here in the code editor, okay? What you're looking at here is a combination of the three technologies that we mentioned earlier. HTML, that's hypertext markup language. CSS, that's some styling, although there's not very much of it in here, and especially JavaScript. Why do we have these technologies together when we're supposed to be teaching you JavaScript? Because as we mentioned earlier, one of the primary reasons JavaScript was developed is to add functionality to websites. And so what you're seeing on the left-hand side here, all of this code, because this is in fact code, this is HTML. You can even see it. It says HTML, right? And it's JavaScript. Everything in between this script and slash script, that's all code, computer code. This is a little teeny computer program. You can even run this thing, and you can see that it does stuff. Now, here's what I want you to do as I teach you these fundamentals of computer programming, these 5 elements in JavaScript. First, remove everything in between the script and slash script. Just highlight all of it. Do not get rid of the script words, just what's in between. So you got some empty space there. All right, now, this is where you're going to do your computer programming. This is where your code is going to go, okay? The first thing we're going to cover is, well, we said that one of the 5 elements of computer programming is there's got to be an entrance point. In JavaScript, it's really simple. Whatever instruction is at the top of the code is the first one that runs, which is pretty intuitive. And most languages work that way, but not always. So let's write our first instruction. We're going to write an instruction that makes a little pop-up appear on the screen that has a message. The command in JavaScript for that is alert. So type alert, A-L-E-R-T. Maybe spell it correctly. And when you enter this instruction, you need to give it some text to include in this little pop-up. The way you give the text to the computer is you put it inside of parentheses. So let's do an open parentheses and some text. Text has quotes around it. So do a double quote, and then we'll say hello, exclamation point. Then do another double quote, and now an end parentheses. You have now included inside the parentheses the information you would like to appear in this pop-up. Now, to tell the computer that you're done with this instruction, do a semicolon. That tells the computer, you've reached the end of my instruction. Take everything you just read and do it. So we can run this code with a big old green run button here, and notice what happens. We get this nice little pop-up, and it includes our text. If you didn't get that as a result of running your code, check to see that you've not capitalized anything or whatever, that you've spelled this exactly properly. Check to make sure that there's no space between the T at the end of alert and the open parentheses. Make sure that you have an end double quote. Make sure that you have an end parentheses, all this stuff. So let's do another instruction. Hit enter again, and we'll do another alert, A-L-E-R-T, an open parentheses, a double quote, and let's say hello again. An end double quote, an end parentheses, and a semicolon. Same pattern. And when you run this, it'll do the first one first. So you get a pop-up that says hello. When you click OK, it then goes on to do the second instruction. It says hello again. Okay, all right. Pretty basic, pretty straightforward. But now let's get into a little more of the fun stuff here. Let's look at variables. So the context we're going to do this in is in the context of what if you were building this Pong game? Well, one of the principal things you'd be concerned with is, did the ball hit the paddle? Is the position of the ball now equal to the position of the paddle? Because if it is, you're going to handle it one way. If it isn't, you'll handle it another. When we were playing that game, when I missed the ball, it ended the game. If I, in fact, hit the ball with the paddle, then it would bounce back the other way and I'd still be in the game. Pretty basic thing. So we're going to work with some variables that are in that context. So let's have a variable for what the ball position is. In JavaScript, one of the most common ways you can make a variable is by using what they call a keyword. That is a word that's part of the JavaScript language. That's what a keyword is. It's part of the language itself. And this word is var for variable. So type var for variable, then give a space. And we've got to give a name to our variable. Remember, variables keep track of data that can change. And you give the variable a name so you can refer to it later in your program. Our name is going to be ball position, lowercase b-a-l-l, capital P for position, and then O-S-I-T-I-O-N. So we've made a variable called ball position. Don't hit enter yet. Just hit a space. So there's two things we need to do. We need to create the variable, which we've done. That's what the command var ball position does. It makes a variable called ball position. But now we need to give it a value. What's the data being held by that variable? What's the data that could change as the computer program works? Well, we're going to give it the value of 100. Now, this is just an arbitrary number we're choosing to kind of teach you a little bit of the coding. The truth is that in the game, we need two pieces of data about the ball. We need, if you look at an XY axis, put this on the screen here, you know, the whole XY axis, we all studied in algebra back when we were in middle school. We need the X position and the Y position. We're not going to make this that complex. There's no need. Let's just say there's a number called 100. That's the position of the ball. Now, again, like any instruction, you should end it off with a semicolon. And now we have create, oh, I messed up. I apologize. Right after the word ball position, hit a space and then an equals. There, I fixed that whole line. So we've done two things in this JavaScript instruction. The first half of this instruction, everything before the equals, the first half, let me highlight it, this creates a variable with a given name. In this case, the name is ball position. This second half, the equals 100, gives a value to that variable. In this case, the value is the number 100. Two things are happening in one instruction, which is kind of cool. All right, so we've made a variable. Fine. Let's use the variable. Remember, I said that you're going to give this variable a name so you can refer to it later in your program. Let's put an alert, one of these pop-ups that tells us what the position is. Well, we know about alert, so let's do A-L-E-R-T. We know that we have to give it an open and closed parentheses. So let's give it the open parentheses. And let's type in here a double quote and then ball position and a colon. And this is part of what we want to appear in that pop-up. We want it to say ball position, and then it's going to list out the number. So here's how you do that. The wrong way to do it is to type out the number 100 because we happen to know that right now the value of the ball position is 100. It's the wrong way to do it. And the reason why is, what if the ball position were different? What if, in fact, ball position was 150? We want a way to make what gets printed on the screen be different every single time the ball position is different. In other words, we need to use this variable we created to create the content. So instead of that 100, let's erase that. We're going to do something really cool. First of all, end off with the text part of this by doing a double quote. Right now, all this alert is going to do is print ball position, colon. That's all it's going to do. In fact, we can do it right now. Let's do an end parentheses and a semicolon, and let's run this bad boy. We run. It does the first instruction, hello. We click OK. It does the second instruction, hello again. We click this. Does the third one. It says ball position. Okay, it works. But we haven't actually included the information from the variable. So click OK. The way you do that is this. Put your cursor right after the last double quote there. Put your cursor right there. And we are going to use the variable. Give me a space. And then do plus, the plus symbol that's right above the equal sign. And now type out the name of your variable. It's ball position, lowercase b, a, l, l, capital P, O, S, I, T, I, O, N. When the computer runs your program and it sees this plus, it says, oh, I need to add some more text. But this is not text. It's a variable. So the computer goes, oh, you're giving me a variable. Oh, let me go find out what the value of that variable is, and I'll print that instead. We know that the value right now of this ball position variable is 100. Run this. There's our first instruction. It says hello. Click it again. There's our second instruction. It says hello again. Click it again. And now it says ball position 100. So everybody changes from 100 to 101. Change the ball position variable to 101 and then run it again. Hello is the first instruction. Hello again is the second one. And now it says 101. I know it's a really simple example, but I just want to illustrate that when you create a variable and it contains data or it has a value that can change while your computer program is running, that can be really useful. What if instead of something simple like this ball position, we're keeping track of the number of items we had in our warehouse of a certain model of car or of, bicycle? Well, you certainly, as a customer service rep for that company, would want to be able to look at a screen, look up that specific bicycle, and see a number that tells you how many we have in the warehouse. That information is stored in a variable. So it's of great value to be able to use variables. And when you're learning a computer programming language, it's one of the first things you should figure out is how do I make variables in this language? And this is how you make them in JavaScript. Okay, so we have covered, let me get a sip of water here. In my May the 4th be with you cup. All right, so now let's cover control and branching statements. Now to reiterate, refresh your memory on that. This is a way to have your program decide between two or more options and execute one of those available options based on certain criteria. Here it's going to be simple. We're going to write out what we do if the ball hits a paddle and what we do if the ball doesn't hit a paddle. Seems like a pretty important thing to be able to figure out when we're making this Pong game. Those are two different, they call them branches, two different sets of instructions that'll happen based on whether or not the paddle and the ball intersect or whether they don't. I'm sure you can see that. So let's check to see whether there's an intersection. We'll go down here to the end of our code here where we said the last instruction was alert ball position. Hit enter. And let's hit enter again just for readability's sake. So we're about to do a controlling statement. We're going to make a decision. One of the most common ways you do that in almost any programming language, including JavaScript, is you use an if statement. So type if, type if, where you can invent a language like I just did. So type if, and when you use this command in virtually every language, what you need to give the computer immediately after this is, what's the condition I check to decide between two or more possible options. And when you do that, you put the condition in parentheses. So let's do an open parentheses. And what we're going to do here is, oh, I messed up. Keep that right there. We have, go back up one line. We have a ball position. You can see where it says ball position 101, right? We need a position for the paddle. So let's make another variable. Let's type VAR, and we'll type out the name of it, paddle position, lowercase PADDLE, capital POSITION. This is the paddle position variable. We have the position of the ball and the position of the paddle. We need a variable for each because they can change while the game is being played, right? Let's say that this one also happens to be equal to 101. All right, now hit enter. So now we know what kind of a condition we're going to have to check. Let's go back down to this if, go right after the open parentheses. We need to check whether or not the ball position and the paddle position are equal. If they are, that means boom, they intersected. If they're not, it means you missed the ball. So the way you do that in JavaScript is you write one piece of data and then two equals symbols, and then another piece of data, and you compare whether or not they're the same. Let's write it out as, first we'll write the ball position, BALLPOSITON. Make sure that you spell it exactly that way. That's what we're going to compare to paddle position. To compare it, you do equals equals. That's two equals symbols. This does a comparison for equality. So then hit a space and type in paddle position, that other variable. PADDLE, capital POSITION. And then you can do end parentheses. Now, stop right there. We're not going to write any more. Make sure you've got it just like I have. And just look at what we have here. This is one of the most important elements in computer science, one of the most important elements in computer programming. When you are able to check whether or not one piece of data is equal to another piece of data, you have a way to control your program. You have a way to make your program make decisions for you. And we have a decision to make. Did the ball intersect with the paddle or not? So everything inside these parentheses, when the computer gets that set of data, it looks at both things and decides true or false. It determines whether or not it's true the ball position is equal to paddle position, or whether it's false. So look at the data as they stand right now. Would this result in true or false right now? Throw it in chat, actually. Let me look at chat. Would ball position be equal to paddle position right now? I've got a false and I've got a true. Okay, let's look at what ball position is equal to. Here's the variable called ball position. Its value is 101. We have a variable called paddle position. Its value is 101. That means the value of ball position is in fact equal to the value of paddle position. So this would result in true. Awesome. Totally understood, Lee. Okay, good. So now that we have a way to compare data and a way to get a true or false, the next thing to do is to give it the two different options. We've got a controlling statement. Now we need a couple of branches. What do we do if they're equal? And what do we do if they're not equal? Well, in JavaScript, the way it works is if you've written if, do a space, and then an open curly bracket. It's usually on the second row, just to the right of the P on your keyboard. So that's an open curly, well, sorry, they're called a curly brace. So it's a curly brace. So do the open curly brace. Now, here's a little pro tip. When you're using an opening curly brace, it has to be paired with a closing curly brace. So every time you write one, You should hit enter a couple of times and then type out the closing curly brace. And that way you never forget that closing curly brace. You could wait until you got to the end of what you were going to type next and then try to remember the curly brace, but you will inevitably miss one. So now go back up to this space we made in the middle, okay? We left that empty line right there. What we will put in here is a branch of code. In other words, an instruction or instructions that will be performed if ball position is equal to battle position. If what's inside the parentheses was evaluated and resulted in true instead of false. So right in here is, what do we do if it's true? What we want to do is we want to pop up an alert that says collision. I know you do a lot more complex stuff inside the game, but we're just demonstrating that you can have separate branches of code. So follow me here. For readability's sake, I want you to hit the space bar twice. Space, space. It doesn't really change how the program works. It makes it easier to read your code. And now let's make the alert pop up that says collision. We've done this before. A-L-E-R-T. You have an open parentheses, and then you got a quote. This is the text. We want to say C-O-L-L-I-S-I-O-N, exclamation point, maybe even 4 of them. There was a collision. End it off with a double quote. You got to close out the parentheses and then do a semicolon. Wait for a second till everybody gets caught up. And I'm going to teach you something really cool. All right, so let's run this. And before you run it, you should predict, what do you think is going to happen? Just think to yourself, what's going to happen? We know we're going to run the hello. We're going to pop up with hello again. We're going to pop up with the ball position. And then what's going to happen? Let's run it. There's our hello. There's our hello again. Sounds like Adele. Then there's the ball position, and then there's collision. And that's what should happen, because the value of ball position is equal to the value of paddle position. Click OK. Now, I want you all to change the position of the paddle. Let's say we moved the paddle, and now it's in position 102. What's going to happen when we run this code? Oh, Rudy asked why the exclamation point. It has no bearing on how the program works. It's just me it's yelling. It's saying, hey, we had a collision. That's all. It doesn't change the computer program, how it operates. It's just different text. It's a good question. And Victor predicts that collision is not going to show. Let's see. Run. There's our first instruction. Hello. Hello from the other side. Ball position. And nothing happens. Why didn't anything happen? Because we only defined what would occur if this condition was true. Now that we've changed where the paddle is, this condition is false, and we need to provide a branch of code for what to do if it's false. The way that you do that in JavaScript is you use an else instruction. So go right after the last curly brace, right down here. This is where I put my cursors, right after the last curly brace. Give me a space and type the word else, E-L-S-E. And now we need to put the branch of code that will be run if the condition up here is not true. If this condition is not true, the branch goes right after the else inside of curly braces. So give me an opening curly brace, hit enter a couple of times, and give me a closing curly brace. Make sure don't forget that curly brace. And then go back up in between them, hit space 2 times just for formatting's sake. And I think you can probably figure out what to do here. We want to have an alert pop up that says missed. So it's alert, A-L-E-R-T. an open parentheses, and inside the parentheses is the text you want to print. We want to print the text missed. Let's include no exclamation points. We could even include a sad face. Oh no, we missed. Make sure you have the double quote to end the text that you're going to print. Give me an open parentheses and then a semicolon. Leave it there for a second. People get caught up. Now, when we run it, we should actually see that we missed. Run. There's the first instruction. Click OK. Second instruction. Click OK. Third instruction. Click OK. Missed. Wah, wah, wah. Okay. So far we've covered 3 pretty important elements of any computer program. And the fact is, if you're setting out to learn any language, Python, JavaScript, C#, Java, any of them, this is a great way to start learning the fundamentals of the language. How do I make my first instruction happen? How do I make variables? How do I do if statements, control and branching? And the next thing would be, how do I make a subprogram? So let's talk about this for a second. How many times during the execution of this game do you think we're going to have to check? Thank you, Biniam. How many times during the execution of this program, while this program is running, while somebody's playing Pong, how often do you think we're going to have to check whether or not there was a collision? Over and over and over and over and over again, right? Well, the last thing we want to do is have to try to figure out how to write a program where every single time the ball moves or the paddle moves, we have to write out those instructions again. These instructions right here. Our computer program is going to be thousands of lines long and really hard to read and confusing. So we have a perfect candidate for a subprogram. We want to make sure that every single time the paddle moves or the ball moves, we immediately check, hey, was there a collision? So let's write a subprogram that can do that whenever we need it to. So go to the end of your code right after that last curly brace, hit enter a couple of times, and we're going to make a subprogram. Now, an important thing to know. The word that gets used for this subprogram concept is different in most languages. Some languages, like JavaScript, they're called functions. Some languages, they're called methods. Sometimes they're called subroutines. Sometimes they're actually called subprograms. It all amounts to the same thing. A mini program that the rest of your program can use on demand. That's what a subprogram is. A small set of instructions, a small mini program that whenever you call on it will do its work, and then your program will pick back up where it was right before it asked for that subprogram to do its job. And you're going to see that happen here in a moment. So in JavaScript, the way you make one of these subprograms, again, they're called functions in JavaScript, is you use the JavaScript keyword function, F-U-N-C-T-I-O-N. This says, hey, JavaScript, I'm about to create a function. I'm about to create a subprogram. And JavaScript is like, great, what's the name of this thing so that you can call on it later on? Oh, yeah. Well, I'm going to call this check collision, capital C, H-E-C-K, capital C-O-L-L-I-S-I-O-N, check collision. That's a great name for a subprogram because it describes exactly what it does. So I'll let you get caught up on that. And then we're going to cover one of the most, man, this stuff is so important, so fundamental, and so fun. Remember that we're designing something that the rest of the program can use on demand. The way to think of this is you have your main program. You start at the top, you do the first instruction, the second instruction, the third, and so on. That's called the main program, and it just goes down in order, one after the other. That's your main program. Think of it as the trunk of a tree. Well, we've already covered that you can have branches. Okay, good, got it. But this main program, when it needs a sub-program to run, calls on the sub-program. It says, hey, I've been busy over here doing steps 1, 2, 3, 4, and 5, but now you're over there, Mr. Sub-Program, and I need you to do your job. And then when you're done, I'll pick up where you left off, or where I left off. That's the basic concept, right? Well, there's two factors involved to think with. The first one is that often that sub-program needs some information from the main program in order to do its job. And sometimes when that subprogram is done doing its work, it needs to deliver some information back to the main program. So R. Anderson says every second or ball position pixel. He's asking, like, how often will we check this? The truth is you do it like every regular period of time. I'm just simplifying this. That was a great question. So back to this concept of writing a subprogram. I'm going to keep using the word function because in JavaScript we call them functions. When you're writing a function, sometimes the function needs some information to do its job. And this is absolutely the case. If we're going to ask this function over and over again to check whether or not there's a collision between the location of the ball and the location of the paddle, we need to give it the positions. So in JavaScript and in most languages, here's how you give the subprogram information. You type in the name like we have right here on the screen. We have check collision, and you put parentheses, and inside the parentheses, you list out the information that will be given to the subprogram. So type in open parentheses. When we ask this subprogram to run, when we ask this function to run, we're going to give it the ball position and the paddle position. So let's type out BALL, capital POSITION, ball position. That's the first thing we're going to give it. And then you can give it another one separated by a comma. So do a comma and a space. This is the second thing we're going to give it. It's the paddle position. PADDLE, capital POSITION. And then an end parentheses. Look at the way that reads. That reads almost like English. Here's a function called check collision, and it takes in two different pieces of data, a ball position and a paddle position. Cool. The only thing that's left is, fine, what's the work that this specific function is going to do when we ask it to do its work? And that work will be inside of curly braces. You've probably seen a pattern here. So hit a space and then an open curly brace, hit enter a couple of times and do your closing curly brace. And now we've made a little bit of room for ourselves on this line right above. So move up one line. This room is where we're going to put the instructions, the quote unquote mini program, the program within a program. When we ask for the check collision function to be performed, these next instructions are what will occur. Now, I don't very often copy and paste in coding, but this is a perfect occasion to copy and paste. Why? Because we already wrote what we want to happen. It's right above us. So follow me very closely here. Go up here and starting right after the curly brace, select all of this, copy it. Control C on a Windows machine, Command C on a Mac. Go down to our nice little empty space and then paste it. Control V on a Windows machine, Command V on a Mac. Now don't do anything else. I'm going to give everybody a second to do that. Again, you are copying this whole chunk right here because we know that works. And you're pasting it in that empty space you left inside of the curly brackets. You give it 3 or 4 more seconds. Now, this next part is important. I'm going to show you something that you will want to do as you learn to code, only to make your code easier to read. It doesn't affect how it operates at all. When you have something inside of curly brackets, it's very helpful to move it over by a couple of spaces. So I want you to select all of this. Be very careful. Follow exactly what I do. Select all of it. Don't do anything yet. Oh, I didn't select all of it. I apologize. There you go. Keep it selected. And now hit the tab key. Notice how it didn't change any of the characters. It didn't change any of the things you typed. It just shifted it all over. And notice, isn't that a little bit easier to read? That's kind of cool. It's easier to read. Okay, good. So now this part's super, super, super vital. I want you all to make a prediction. Look at this code we have. We've got our first instruction, our second instruction, and our third. Those things are pretty old hat by now. We have this if, this control and branching thing that we set up. And we've operated that a few times already. And now we have a function. So my question is, what's going to happen when we run our program? Specifically, right now, ball position and paddle position do not match. So my question for all of you is, when we run this, how many times are we going to see the pop-up that says missed? I'll give you a second to think about that. Rudy says 2. Just think about that. You can put an answer in chat if you want to or not. Now, Victor says it'll show every missed frame. That's true in the real program. I'm saying as this program is the way it exists right now, we've written this program. We know that paddle position is equal to 102 and ball position is equal to 101. They don't match. We have this control and branching thing up here. We've already tested this. We know that it works and it should give you an alert that says missed, wah, wah, wah. But we've also built this function. And it's designed to check whether ball position and paddle position are equal. And if they're not, it should say missed. So my question is, when we run this, how many times will we see a pop-up that says missed? Let's run it. There's the first instruction. Victor, you hit the nail on the head. We'll talk about it in a second. All right, click OK. There's a second instruction. Click OK. There's the third. Now go slowly. When we click it again, we're going to get the if from up here. Click OK. It says missed. Click OK again, and nothing happens. We only saw the alert that says missed once. Why? Aren't we telling the computer to check it right here again? Aren't we checking it twice? We checked it right here. Isn't this also checking it? And this is such a critical piece of information that I'm going to cover right now. It confuses a lot of early learners. It confused me many, many years ago. Shut up, I'm old. Let's go back to the central concept of what a subprogram is. It is, in fact, a program within a program. That's a very gross simplification. Get it? Gross, that's my name. So it's a gross simplification. You need a little bit more nuance to really grasp it. And it's what I was talking about a few minutes ago. A subprogram is a mini program that can be called upon to do its work. And that can is the critical piece. Merely creating the subprogram does not constitute calling on it to be executed. All we've done is we've defined potential behavior. We've defined a mini program that could be used if we want it to somewhere else in the program. But we never asked for it to be used. And that can be a little bit confusing when you're getting started. Awesome, Lee. Yeah, that's a good aha moment. Okay. So now let's call on that subprogram to be executed. I want to show you a real important thing. First, go above this function. Hit enter once or twice. Give yourself a little space here. Let's see if we can successfully get this thing to run. Actually, I don't know. That's the wrong way to do it. I don't want to do it backwards. Go to the very end. Go to the very end after the final curly brace. Hit enter a couple of times. We'll come back and I'll show you a different lesson. So let's call on this check collision function. Again, it's a subprogram from a conceptual point of view. In JavaScript, we specifically call it a function. We have this function we're going to call. The way you call the function is real simple. You type out the name of the function. So let's type check collision. Make sure you spell it right. There's nothing wrong with copying the name of it and then pasting it. That will guarantee you get it correct. Now, remember, when we are calling on this function, it requires some information. It's saying, all right, I'll do my job, but you got to help me out. You got to give me some data. The data it needs is, well, we see it right here. It needs a ball position and a paddle position. So that data goes inside of parentheses. So let's use the variables that we have up here. We have a ball position variable. We have a paddle position variable. Let's give it that data. So let's give it ball position, like that. Victor asked a really important question. Let's finish writing this out and then I'll answer it. So we gave it ball position. Now let's also give it paddle position. And then do a semicolon. That's the instruction. That's the way in JavaScript. This is the way you call a function to be executed. Up here, we defined what the function is. We showed how it would work if you want to use it somewhere else. Here, we're actually using it. We're calling it by name and giving it the information it needs. It will then do its job. It'll execute these instructions. So now run your program. We get the first instruction of hello. Second instruction, hello again. Third one is the position. Fourth one is our if. And the fifth one is another if. Another missed. So we saw two of those. They appeared so fast, it's hard to tell, but you know because you clicked on it. Do it again. This is the first one. Click, 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 and then click. So we got two of these pop-ups. Awesome. All right, now, Victor, he asked a really good question. I know it's not Q&A, but this will take up a little bit of our Q&A. He says, why do we make the function with a capital C? My variables are with a lowercase. It's not required that way. It's just a very common pattern that you see in JavaScript development. We could just as easily make this a lowercase c, and then when we call it, we could have it, there it is, lowercase c. But it's very common in most computer programming languages to have variables start with a lowercase and functions start with an uppercase. It's not required. It just makes it easier to read your code. I hope that works. Also, Victor, you said, is that a rule for functions in Java? I just want to, this gives me an opportunity to stress. Java and JavaScript are utterly and completely different languages. The fact is they have, and this is amazing, they have nothing to do with each other. Java and JavaScript are not connected in any way at all, period. Java was really popular back in 95, 96. And when they came up with this language to use for the web, they needed a name for it. And they came up with JavaScript because Java was popular and it was a marketing ploy to make the language popular. That's all it was. But they've got nothing to do with each other. Java is a completely different language. Okay, isn't that bizarre? Oh, that was crack me up. All right, now, let me show you two things about these functions, okay? Sybil says, why is JavaScript the easiest language to learn and the hardest at the same time? I feel you. I feel you. Okay, from a certain point of view, any language is the easiest and the hardest to learn at the same time when it's the first time you're learning to program. It's just, there is a fair bit to learn. Look, we'll talk about this more later on, but our programs are like 4 or 5 months long, and they're intensive because there's just a lot you need to know to be a well-rounded entry-level developer. But what do they say about how to eat an elephant? One bite at a time. Just do the next thing. We'll talk more about that later on, okay? Now, I'm going to show you 2 more things about functions as we get towards the end here, okay? The first one is really interesting. Let's see what happens when we change the data. Remember that up here, we had ball position at 101 and paddle position at 102. Let's change them. Right above the check collision, let's say ball position equals 500, and then paddle position also equals 500. So they moved a lot. Now run this. We get our first one, second one, third, the fourth, and the 5th one says collision because they were equal. So that's just to show you, hey, we can call this over and over again. We could do it again. Hit enter. Let's do ball position. I didn't capitalize the P. Equals 501. The ball moved. But the paddle didn't. Paddle position still equal to 500. Now run it. Oh, wait. We didn't call it. We have to call it again. So let's call our check collision. We'll call ball position and paddle position. See how we're calling it again with new data. So let's see what happens when we run it. The final one should say that we missed. There's the hello again, the ball position. This is the if statement. Here's our collision from right here when they were the same. Hit OK. And now it says missed. That's from down here. All right. Last thing I want to show you is this. Above the check, the function declaration, let's call check collision again. You type this out a number of times, you should be able to follow along with that. Anybody have an idea what's going to happen when the computer gets to this line right here? Pop it in chat if you have an idea. Rudy says nothing. Good. Remember that at this point, ball position is 101, paddle position is 102. Victor says you're calling the function before it's made, so it won't work. Yeah, Victor, you're pretty smart. Let's run it. There's the first instruction. There's the second. There's the third. There's missed. And it didn't run it. We should have a missed and another one immediately after it. Let's go. Hello. Hello again. Ball position. Here's the first one on the if statement. Missed. Click it again. There's another missed, but it's this one because when we hit it again, it's collision. This one did not execute. It didn't happen. Why? Why is that not happening? And it's what Victor said. The function was declared down here, but we tried to use it before it was even created. And this is just a behavior of certain languages. You can't use it until later in the code after you've defined it. It's a minor thing, but it's just kind of fun to think with. All right. Let's switch to the next step here. Give me a moment. All right, so there's a free gift here in a moment, but I want to do a little bit of Q&A. We already answered a few questions. I think we have time for one. Is there anything we missed in questions inside here, Regina?
Not that I see, but if we missed your question, feel free to retype it in the chat or copy and paste it.
Yeah, and we'll also have a way you can email in questions afterwards, okay? All right, so we'll watch that. All right, so I want to take a moment here to talk about us, who we are, and the boot camps. So please stick around for our free gift that we have at the end of this. And I'm just going to be completely upfront about this. If you have at all considered the idea of a career in technology, you owe it to yourself to listen really closely to what we're going to cover here. This may be a fit for you. It might not be. But for those people where it is a fit, you're honestly looking at an incredible opportunity. There's a bunch of ways to get into technology. We did a presentation on that a little while ago, okay? But there's some special things about how we do it. First of all, we have 12 different boot camps. There's a lot of disciplines in technology. And we cover every major area of operation in tech inside these 12 coding boot camps. We cover artificial intelligence, generalized computer programming, web development, cybersecurity, which is highly in demand right now on account of insecure websites and programs cause a lot of damage. And so companies pay well for people that can protect them. We cover things like data science, increasingly popular, video game development, really popular, mobile app development, right? In fact, we have more certification programs than any other coding boot camp on earth. And how do we run those programs? This is where the difference comes in. Our programs are self-paced. That's critical. A lot of educational methods that are used all around the world are very linear. Everybody moves through the material in lockstep at the same pace, but people do not learn at the same pace. Everybody learns at their own pace. And we go into a lot of detail about how we arrange that, but the programs are able to be completed with tremendous effectiveness with you going at your own pace, which is pretty cool. And you still receive instructor support all the way along. No problem, Lee. Thanks. The content we cover is well-rounded and it's very in-depth. Even in the confines of a boot camp, where we have this relatively brief intensive period, we're able to give you a lot of depth in each subject so you can actually, we talked about this earlier, so you can actually use it when you get on the job. So another cool thing about this is our boot camps are really affordable. Look, it's an investment. Anything that's going to change your career is an investment, but we're well under the national average. And probably more importantly, it's one thing to do the training, it's quite another to get the job. All of our programs include both job placement training, like actually learning how to get hired in tech, and job placement assistance as you embark on that quest to get hired, right? Now, and this is the most important. All of our programs are designed for absolute beginners. There's no technology knowledge or experience required. So you don't have to be a nerd who's lived and breathed this stuff already for a long time to make it through our programs. And we've tried to give you a taste of how we approach the learning process. And even in the confines of an hour, hour and a half, I hope you've seen a little bit of it. The whole program is like that. Simple, clear, easy to understand the definitions. Lay in the fundamental foundations of a subject before you start to bury yourself in complexity. Arrange things in logical order of complexity. Provide practical experience so you can get your hands dirty and gain the certainty that you can actually do the job when you hit the market. That's how we arrange our programs. And it's being acknowledged in the marketplace, right? These are some of the awards we've received over the years. We consistently land on every major best coding bootcamp list. There's a lot of agencies and companies that rank these kind of things, right? And this is what we hear from our graduates. This is student and graduate feedback. We have an average 4.8 star review rating across all major review platforms. We're really, we just love hearing from our students and our graduates that they're doing well. It's really, really cool. So here's the thing I want to ask you is, why would you consider working in technology? This is a very personal thing. It's a career shift. For some people who have not yet embarked on a major career in their life, it might be like, what's my major thing I'm going to do in life? For others who are already working in one industry or career, why consider a shift to tech? There's a few things I'd ask you to look at. One is that the work-life balance in technology is in general very, very good. We're very valued in our roles, and with uniformly across the board, we're very rarely ever overworked. We contribute greatly, don't get me wrong, but not at the expense of like 60, 70, 80-hour weeks or anything insane like that. And there's a lot of remote work opportunities, if that's something that really fits into how you like to work. Some people like being in the office, some people don't, okay? But the point is that work-life balance in tech is really, really good. It's also a very creative industry. For all that you're working with machines, right? These mechanisms of metal and plastic and pure logic and all this stuff, the actual activity of building software that satisfies people and meets needs is a really creative endeavor. And when you get done creating something really cool as part of a team or on your own, you can take a lot of pride in your work, which is really neat. It's also a very stable industry. We see these brief fluctuations as things shift a little bit in the economy, but if you look over the last 40 years, it just gets more and more and more in demand. I can go real nerdy and deep on this, but the short version is that at any given point in time, and this has been true for about 25 years, at any point in time, the number of existing job openings in tech is much, much greater than the available number of technology workers. It doesn't mean you're just going to walk out there and just like, hey, give me a job. You've got to work hard at it, and we go through that. But it's the truth, and it has been for decades. There's always more jobs available in tech than there are available people to work in tech. So if you apply yourself and learn it well, and you're a really decent, nice person who works well with others, you can and will get hired. And of course, it pays well. I mean, I think that's pretty well known. Technology jobs pay well, and you get regular increases in pay as you advance, which is great. So what are the barriers, though? Those things all sound awesome. What are the barriers? Well, there it is. My Zoom is Google presentation or Google Slides is being really erratic right now. Okay, so let's just face some things. There's money and time and technical ability. So let's look at the money thing. I'm not going to beat around the bush. Boot camps are expensive. It's the truth. Now, college is super expensive. That's 4 years, $100, $150, $200,000, right? But boot camps are expensive. They can cost thousands of dollars. Now, besides the fact that we are priced well under the industry average, what we've done to try to make that a lot easier to confront is we've got multiple financing options. We have upfront discounts. We have monthly payment options. But ultimately, this is the thing I'd ask you to look at. An investment in the Tech Academy and getting through one of these programs is truly just an investment in yourself. There's no greater asset that any person can have than their own personal certainty and confidence in themselves. And that's true in any industry. But if you're going to go into this industry, the most important thing you can get out of any program you go through is, are you increasing your certainty and your confidence in yourself? And that's worth investing in. The next thing we talk about is time. I said it, you got a lot to learn. It can be learned. We have people that graduate every day They get through this program and they're doing great, but it requires a time investment. Now, some boot camps approach that problem of time with a cohort approach, where they have classes that start at regular intervals. They group a bunch of people and they all start on the same day and they all move through the curriculum at the same exact pace and lockstep. Again, we found that that leaves some people behind and we're not interested in that. So you don't have to wait to start, right? Some boot camps have in-person training only, right? Which is really challenging for you in terms of managing your time. Our programs are fully online. Yes, we have a campus in Portland. You can go there if you want. It's awesome. But most people do this fully online. And most importantly, you can choose your study schedule, whatever fits in terms of how you've arranged your life, as long as you can commit to a certain amount of time each week to really devote to it. Because again, it takes some work. You can be flexible in how you arrange that time, which means you can study concurrently to holding down a job or doing other schooling, which is pretty cool. Okay. That's the time picture. And let's talk about technical interest and ability. I said earlier, you don't need to be a nerd to get through this. I joke about myself being a nerd a lot. The truth is I am, and I'm fine with that, right? But set that off to the side. Technology should be available to everyone. Careers in technology should be available to anyone, right? And the fact is that I mentioned it earlier, a lot of technology education materials, they're just too hard. And that's not a reflection on the learner. It's a reflection on the curriculum design. So if you have even a remote little bit of interest in technology, a remote little bit of ability, when you impact with poorly designed curriculum, it can blunt that interest. And that drives me up a wall. And the root of all of it is when you're doing curriculum design, if you assume too much prior knowledge on the part of the learner, you'll ruin their experience. And that's on you as the designer of the curriculum, not on the learner. And so that's built into how we designed our boot camps. What it means is, again, you don't have to be a nerd to get to these programs. You don't have to have any technical background needed to enroll. We've taken care of that part for you. Be reasonably bright, read, write, do basic math, and you can get through it. All right, so that's the question is it time for a change? I've got a few questions for you. Are you, for example, working in a dead-end job? Maybe you're happy with it, maybe you're not, but when you start thinking, where am I going to be in 2, 3, 4, 5 years, it just doesn't line up with what you want in life. Or maybe you're unemployed. That's happened, right? Bright, hardworking, something happens with the industry and you're not working, right? Or do you want to work from home? You're doing a physical job where there's no possibility ever of doing it remotely. Tech allows that. Or do you want more time with your loved ones? The flexibility in terms of work-life balance to be able to work remote or not be working 50, 60, 70, 80 hours a week, right? The whole point is it time for a career change? I'm not saying it is or isn't. That's your question to answer. But if it is, this could be a viable option. And Victor, that's a great question. I'll get to that for a second. Okay. So this is what we're all about. We are the bridge between people and technology. Now, we do that in a lot of different ways, but when it comes to the career in technology, we're very effective. Most Tech Academy graduates make $30 an hour on average in their first job. That's $60,000 a year. So you can attain that in a matter of months, which is awesome. And because of that, over time, we become career change experts. We can help you transition from one career that you're already in into tech very often without taking a pay cut in terms of your compensation, which is pretty cool. At this point, we've got over 1,000 graduates working in tech in all kinds of companies, from small businesses to the big, like technical position, the big companies like Nike, Facebook, Disney, Uber, Epic Games. We have people working in all those places, right? Not everybody's in one of those big giant companies, but they're working in tech and they love what they do, right? So as a reminder, we offer open enrollment. You can start anytime. And if this resonates with you, I encourage you to enroll now. Now, how do you do that? Here's how. You go to Erik's special link at learncodinganywhere.com/Erik. It's a simple form on there. I think it's got 3, maybe 4 different things to enter in. It's real simple. And then once you've done that, it takes you through a series of educational steps that will help teach you about the school so you can make an informed decision. There's videos, articles. There's even an optional step to book a call with admissions and talk to a live human being who can answer questions for you, right? So I encourage you, if this seems like it might work for you, to apply and then finish those steps after the event. And I'm going to wait about 1 or 2 minutes for anybody to fill that in. And I'm going to look at this question that came in. Sybil says, once you graduate, you start as a junior software developer. It's a great question. Most people, that is the role that they go into. But because we have these 12 different programs, Sybil, it isn't always software developer as the role they go into. Some people go into UI, user interface, user experience development. Some people go into program management because they really have a drive towards that. Some people go through, front-end web development, but they're junior level technology positions. The exact area depends on what you enjoy, which program you did, and what the company that hires you wants you to attack as their first, your first area of discipline. But I'll tell you this, we concentrate so well on the fundamentals and on how to learn new technology on your own that no matter where you get put in that junior role, you can excel. What programming language do you learn in the game design program? Regina, I believe, I know it's C# because we use that in Unity, but I think we also cover some C++ because that's used in, in the Unreal Engine. Is that correct, Regina?
Yeah, I can read off some of the courses in that boot camp.
Oh, yeah.
Just
one of the attendees is a current student. He says, yeah, C++. Because I know that Unity, a major, super popular game engine, utilizes C# on the back end to write the actual code. And then Unreal Engine uses C++. So yes, you cover both of those when you do the game development one. Yeah, that's a really great question, Sybil. All right, I'm going to give it just a second more for anybody to fill this out. And by the way, if you go to that form and it instead pops up a login screen, it just means you've already created an account with the Tech Academy, and you can use this data at the bottom of the slide to figure out your username and password. Thank you so much for that help, Jeremy. All right. So let's talk about our referral program. Since graduates love us, referrals are one of the top sources of enrollment for the school. So years ago, we instituted a commission payment for all enrollments. If you refer someone, you get a 5% commission payment. Period. End of story. If you're responsible for them getting in touch with the school and they sign up, we cut you a check. So in a moment, there'd be an opportunity to email in to get your free gift. You can include in there name and contact info for people that you think should be talking to us about the school. We'll keep track of that, and you will get a commission fee, which is pretty cool. So let's talk about our books, because we're getting to the point where we're going to give you a free gift. Over the years, the Tech Academy has published 7 publications, including 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, a technology basics dictionary, a project management handbook, and You Are Not Stupid, Computers and Technology Simplified. This book, You Are Not Stupid, is amazing. Obviously, I'm biased. Jack and I wrote it. But nothing like this existed beforehand. It's something that will clear up all the mystery and confusion around every aspect of computers and technology. What we did is we took one of the most important courses on our curriculum. It's the first course everybody does, called the Computer Basics course, right? And we included all of that, fleshed it out, included background data on the history of technology to be able to give someone a very clear picture of how we got where we are and how to work with technology in every aspect of life. That's You Are Not Stupid. Victor says, in terms of the referral program, even if you aren't a student or only for students and graduates, it's for anyone, whether you're a student or not, you are eligible for the referral program. That happens quite often, where we pay out referrals to people that aren't in the program, and we love doing that. Good question. All right. So here's the free gift, right? It is we have this Learn Coding Basics in Hours with JavaScript book. Now, we were able in this hour-and-a-half period to cover a few fundamentals. We were able to cover these 5 basic elements of any computer program, and we were able to demonstrate how they work in JavaScript. This book expands on that greatly. You'll learn a lot more about those 5 basic elements, and you'll learn a lot more about the fundamentals of JavaScript, and you can get through it in about 8 hours. It's really, really cool, okay? So that's the Learn Coding Basics in Hours with JavaScript. And you can have a free copy of it. It's a physical book. Just send it an email to books@learncodinganywhere.com. And I just want to clarify. Every once in a while, we have people that drop their email address into chat. That's not how this works. Send us an email with your name and your physical address, please. We're actually going to send you a real book, right? Give us your physical address, and we'll send that off, okay? And again, this same email is where you can include any questions we didn't get a chance to answer. And you can also include any referrals, people that you think we should be talking to. Now, one last thing. I'll give it a moment for people to want to finish that email and take a sip of water. Okay, so Regina, if you could drop the Linktree link, thank you so much. When you go to this Linktree, it has all of our socials, a whole bunch of other stuff. You'll find links to our free educational YouTube video playlist, which is where these recordings go to, by the way, right? You find links to our books, our dictionary, all of our upcoming events. You'll see links in there, right? Our upcoming meetups and all of our social media accounts. So here's the ask. One, if you like anything about this training or our company, follow us on social media. Please invite your friends to these future meetups, these classes. We want to see everybody. We just like helping people, right? And this part is pretty cool. You have an opportunity to win a free copy of You Are Not Stupid. This is a hefty book. It's $20-25. We don't just like send these out all the, for free all the time. It just wouldn't be affordable. But if you will help us, we will help you. If you will share a link to the next event we're having, you can find it, at that link tree. If you'll share a link to the next event and tag us in that share, we'll enter you in to win a copy of You're Not Stupid. Regina, who was it that won last week?
Jose Silva.
Excellent. Good. So we're sending out a copy of that just because he was awesome. And it was really cool. He even took screenshots of some of the training he enjoyed and pulled his name out of the hat, and he's getting a copy, which is great. So if you'll share a link to the next event and tag us in social media, then you're in the running to win a copy of You're Not Stupid. And again, we'll just send it to your house. By the way, if you have people in your life that aren't tech savvy and you're constantly getting pulled in to be tech support for them just because you have some sort of affinity for the area, make them read this book. Guarantee you they will not be calling you as much. They'll be able to handle some of their problems themselves. Thank you very much. Not that that ever happens. All right, so what are your next steps? Well, again, this is the link to go to find, to apply, to find out more about the school, say, hey, I'm interested. What are the various boot camps? How do they work? When you log in there, there's a series of steps to go through. Please do that, okay? And thank you so much for attending. Super appreciate it. I love teaching this. I love how involved you were as a class. All of your questions were spot on. They were great, okay? Hideo has an awesome question. I'm going to say this. We're done if you want to drop off. I'm actually going to answer Hideo's question right now just because I enjoy it so much, but there's no need for you to stick around if you don't want to. Hideo asks, due to the recent technology advancement around generative AI, do you foresee programmers' required skill will change? Will the school of the curriculum change in the next 1 to 2 years to align with the business context? That's a fantastic question, Hideo. I'll take up the final part of it first. In terms of curriculum change, we have created an artificial intelligence developer bootcamp because it is an incredibly vital area that pays well and where you can make a big contribution. So that's the first thing, okay? So we can call that curriculum change. But, Sally is totally spot on. Will you be sharing the Pong game code? I'm so sorry. Let me grab it right now. I'm going to stop sharing for a second, and I will share the link to it. No, it's really not nice. I just put it in the chat. Oh, did you? Thanks so much.
Yeah.
Okay. So let me get back to that question because I love that question. Okay. So due to the recent technology advancement around generative AI, do you foresee programmers' required skill would change? Not fundamentally, only in the particulars. And here's what I mean. The state of AI right now is such that all it can do, and this is not to minimize it at all, it's very powerful. All generative artificial intelligence can do is generate text. It can't understand anything. It has no life to it, and probably never will. It can generate text. Now, here's what's cool about it. If you are talented in asking generative AI like ChatGPT, if you're talented in asking very precise questions about the type of text you want to generate, it can give you very useful output. We did a whole training on this, by the way, about 2 or 3 weeks ago. And Hideo, you should go to that free YouTube channel we have and look up the one from a few weeks ago about ChatGPT. And that will probably help add more nuance. Okay. But the fact is that all it is a tool that will help you do your research faster. It will give you mostly or almost totally useful code snippets. But in terms of the real work that engineers do, it can't replace it. Here's what I mean. We solve unique human problems related to specific real-world business challenges faced by our employers. And there's so much variety to that, so many myriad factors involved, that the most important work we do is understanding the problem domain and crafting a technology solution that will play nice with sometimes dozens or hundreds of existing computer programs already in use at the company, and making sure what we build will fit into that ecosystem well, will be able to be maintained long term, and will deliver the required value to the customer. Artificial intelligence doesn't even come close to solving that kind of a problem. All it is a tool to increase your productivity. So I'll say that programmers should add to their skill set of being able to use these generative tools in a much more intelligent manner, but they should never for a moment think that what it's doing is actually programming. It's just generating text that you can use in a program that you and a team have created that competently addressed a real world problem with all those factors. That's a long-winded answer, but I hope it kind of added a little bit of nuance to Hideo. Does that help? I hope Hideo is still here. Awesome. Yes. Thank you. Excellent. And yeah, in terms of the curriculum, we're constantly staying up to date. Like, one of the reasons I continue to be a working software engineer all the way through the entire existence of the Tech Academy is so I can be out there in the mix with other engineers and see what's really in demand. And so whenever we have like any coordination meetings on curriculum, I'm able to give advice based on what's really in use. And right now, in terms of AI, there's two things. One, specialize in that area. So we made an AI developer bootcamp. And two, yes, prompt engineering, being able to artfully and precisely craft the prompts that go into these things. It's a valuable tool. And so, yeah, we do update our curriculum based on that and all the other factors that change. Excellent. All right, cool. Thank you all so much. I appreciate it. I'm going to hop off now. Please come to our next class and shout us out on social media. And again, if you're considering career change, you really can't go wrong with tech. And obviously I'm biased, but our route into tech really works. And I think you'll enjoy it. Have a great day. All good. Regina dropped the link to the next event right there in chat. You can grab that if you want to. Have a wonderful day, folks.